Welcome to the future of clean. Tired of endless sweeping and hoovering? Wish you had a little helper to tackle those dust bunnies? Well, good news everyone. Building your own cleaning robot is easier than you think. No more forking over a fortune for fancy RoboVacs. We're going DIY, keeping it budget-friendly and having some fun while we're at it. This guide will walk you through every step, from cardboard construction to basic coding. Let's get this cleaning party started. Before we start building, let's gather our cleaning crew, the materials that'll transform into our very own robot. Don't worry, we're keeping things simple and affordable. Here's your shopping list: sturdy cardboard. The bigger, the better. This will be our robot's chassis. DC motors, 2 of them. These are the muscles for our bot, powering its wheels. Wheels, also 2. Pick ones that fit your motors snugly. Battery pack. Choose one with enough juice to power your bot. Microcontroller. This is the robot's brain. We'll use an Arduino Uno for simplicity. Breadboard and jumper wires. These help connect the electronics neatly. Suction fan, the heart of our cleaning operation. Switch to turn our robot on and off. Hot glue gun and glue sticks, our trusty tools for quick and easy assembly. Basic tools: scissors, a ruler, a marker, and some tape. Now let's build our robot's chassis. Its sturdy cardboard frame. Grab your cardboard, ruler, marker, and scissors. First, cut a square. Start by cutting out a square from your cardboard. This will be the robot's base. A good size is around 30 centimeters by 30 centimeters. Next, motor mounts. Cut out 2 smaller rectangles for the motors. These will be attached to the underside of the base, one on each side. Then, secure the mounts. Using hot glue, securely attach the motor mounts to the base. Make sure they're parallel to each other. Finally, reinforce. For extra sturdiness, you can add strips of cardboard along the edges of the base. It's time to wire up the brains of our operation, the electronics that will bring our robot to life. First, connect the motors. Connect the positive wire of each motor to a separate channel on the breadboard. Connect the negative wire of each motor to the ground rail on the breadboard. Next, power up. Connect the positive wire of the battery pack to the positive rail on the breadboard and the negative wire to the negative rail. Then, Arduino time. Connect the Arduino Uno to the breadboard. Connect the digital pins that control the motors to the corresponding channels on the breadboard where the motor wires are connected. Finally, switch it up. Connect one leg of the switch to the positive rail on the breadboard. Connect the other leg to a pin on the Arduino that will control the power to the motors. With the circuitry set up, let's get our robot moving and cleaning. First, we'll be attaching the wheels. Slide the wheels onto the motor shafts. Make sure they fit snugly. You can use a bit of hot glue if needed. Next, we'll focus on the suction power. Mount the suction fan to the underside of the base, facing down. Position it strategically for optimal cleaning. Secure it with hot glue. Finally, let's connect the fan. Connect the positive wire of the fan to a free channel on the breadboard. Then connect the negative wire to the ground rail. And there you have it, your robot is now ready to roll and clean. Now, let's carefully position and secure the electronics on our robot. First, find a suitable spot on the robot base for the Arduino Uno. You can use double-sided tape or even create a small cardboard enclosure for it. Next, place the breadboard near the Arduino, ensuring the wires can reach their connections. You can use hot glue or tape to secure it. Finally, neatly arrange the wires and secure them with tape or cable ties. This will prevent them from tangling or getting caught in the wheels. Time to give our robot its cleaning instructions. This basic code will make the robot move forward, and you can customize it to create different cleaning patterns. CPP//define motor pins const int motor 1 pin 1 = 5. Const int motor 1 pin 2 = 6. Const int motor 2 pin 1 = 9. Const int motor 2 pin 2 = 10. / define switch pin const int button pin = 2. / variable to store button state int button state = 0. Void setup. / set motor pins as output pin mode, motor 1 pin 1 output, pin mode, motor 1 pin 2 output, pin mode, motor 2, pin 1 output, pin mode, motor 2, pin 2 output, / set button pin as input pin mode, button pin input, void loop, / read the button, state button state = digital red, button pin, / if button is pressed, turn on motors if, button state = high, motor 1 / motor 2 / stop motors. The suction fan is key to our robot's cleaning power. Here's how to maximize its effectiveness. First, we already mounted the fan in step 5, but experiment with its position to find the sweet spot for picking up debris. You can use cardboard or tape to create a funnel-like structure around the fan, directing the airflow toward the center of the robot for optimal debris collection. Time for the grand finale, testing our creation. Place the robot on a clear surface and switch it on. Observe its movement. Is it moving forward smoothly? If the robot isn't moving or turning as expected, double-check your wiring and code. Make sure the motors are receiving power and that the code is uploaded correctly to the Arduino. Next, scatter some small debris like scraps of paper or dry cereal on the floor and let the robot loose. Observe how effectively it picks up the debris. Congratulations, you've built your very own cleaning robot. Now sit back, relax, and let your little helper tackle those dust bunnies. Remember, this is just the beginning. You can get creative and customize your robot further. Add sensors for obstacle avoidance, experiment with different cleaning patterns, or even give it a cool paint job. Happy cleaning!